Hello everyone, now we are going to start our next chapter, that is linked list. So a linked list is a linear data structure, So up to now we have studied two different kinds of linear data structures, that is arrays and array list. So an array will look like this. Here you can store elements like 1, 2, 3, 4 and so on. Here the size of array is fixed. Whereas to tackle this problem, we have studied another linear data structure, that is array list. So array list will look like this: 1, 2, 3, 4 and so on. Here the size is not fixed, we can alter or we can change the size of array list, whereas in arrays the size is fixed. And these are the two different linear data structures we have studied up to now. Now we are going to study another interesting, at the same time very easy linear data structure, that is linked list. So the visualization of linked list will look like this. Here we will have elements and each element will have a link to the next element. Let us consider that this is our first element, second element, third element, fourth element. Now this first element will have a link to the second element, and second element will have a link to its next corresponding element, and this third element will have a link with the fourth element. And each element in our linked list, we call it as a node. So a node will have a link, this is known as a link, or you can say chain. So each element is interlinked with one another. So this interlinked process, this interlinked structure, we call it as a linked list. Here you need to understand two terminologies in our linked list. So in a linked list, let us consider that the visualization of linked list will look like this. Here we are storing elements. Let us consider 1, 2, 4 and 5. So the first element in our linked list, we call it as head, and this head will point to its next element by a link. We'll talk about what is this link, how we can create elements, how we can add elements in our linked list. We'll talk each and every operations in the next video, but for now we need to understand the terminologies here. So each element will have a link. Here is the link, and this link will point to its next corresponding element. And the last element in our linked list, we call it as a tail. So by using tail and head, will perform various operations. So the first element in our linked list, the first node in our linked list, we call it as head, and the last element in our linked list, we call it as a tail. Now let us understand how a single node will look like. So let us talk about a single node. In a single node is divided into two types, that is data type, what data we are storing in our linked list. It might be integer, it might be a character, it might be a boolean value, it might be a float, it might be a double, whatever we are storing, we need to declare in the first half of my linked list. And in the second half, we are going to, you can see that we are forming links. To form links, we use a variable, that is reference variable. So here I am creating a reference variable. Let us consider next. So next is a reference variable. So what a reference variable? You can see that in OOPS chapter we have talked about reference variable. So reference variable are the variable which points to an object, So these points to a next node, next corresponding element. Here again in the next node also we will have some data, and it will have some next. After it will point to another node, data and next. After it, if there are no elements in the next of this particular node, then it will point to null. So next is called it as reference variable. So reference variable will point to an object. So here this is a node, and this is another node, second node, third node, and if there is no node, then this next will point to a null value. So what is null? Null is nothing but nothing basically. Now we know the blueprint. We know that a single linked list will have two things, that is a data type and a reference variable. Reference variable will point to its corresponding next node, and that next node will point to its corresponding next node. So you can see that a linked list is divided into two halves, that is first one is data type. What data type we are storing in our linked list, and the second type is reference variable. So we know the blueprint of our linked list now, the blueprint of our linked list. So if we know the blueprint, then we can create the class, and by creating class we can implement our linked list. I hope you got my point here. So we know the blueprint. So what are the blueprint here? A data type and a reference variable. That's all. Now let us create our class. So I'm going to create my class, public class. Let us call it as node. So in node, what are the things we are having? We are having two things. That is, let us consider that I am creating integer data. So int data. After that, node next. So node next. This is the first time I'm thinking. I'm like you guys are seeing that this data type next reference data type is a node, is class itself. So to point out, to create reference variable, we have to write our class name, after that our variable. After that we can create a constructor, public node. I can pass here data, int data. In the data I can give this dot data is equals to data. After that this dot next is equals to, I'm pointing it to null. So this is the blueprint, this is the class of my node. By implementing the node class, I can create my linked list. So let us see, and you would have to understand terminologies here. So the first node in our linked list is known as head, and the last node in my linked list is known as tail. The null value is not tail, but the last element, the last node, that is known as tail. So I hope you have understood the terminologies here. The first element is known as head and the last element is known as tail, and every node will have two things, data and its next reference. Next reference will point to a next node. Basically you can see that here it is pointing to null because there is no element when we create a node initially. After that let us implement this data structure in our VS Code. Here I have created a class, I have created a file, that is linked list. So first of all I am going to import java.util.star. After that I am creating a my class, public class, my file name linked list. This is basically our boilerplate, and in this we can create our node class, public class, public. I am creating a static class because throughout the program our class node is same. That's why I am creating in static format, static class node. In this, what are the things we are having? Int data. After it, node next. We can create our constructor, public node int data. We are passing a value here, parameterized constructor. This dot data is equals to data. After it, this dot next is equals to null. Initially we are pointing our node to null. After that I can create my head, public static type node head. After that, public static node tail. After that I can create my main function, public static void main string args. After that I can implement my linked list. So how I can implement? First of all I am writing my class name, my object name is equals to new class name. So linked list is my class name, linked list, let us say ll is equals to new linked list. So this is how I am going to implement my linked list in my Java folder. Now if I want to like add elements in my linked list, suppose if I want to create head, that is my first element in my node, how I can create? I can create ll dot head is equals to new node of, I am passing 1 here. So here this is how I can create. So I have successfully created the head in my linked list. but we are not gonna do like this ll.head, ll.tile. We are not gonna do these kind of things, these kind of syntax to add or delete elements in my linked list. Instead of that, we are going to create methods. We are going to create methods for adding, comma, subtracting, comma, deleting, comma, searching element in my linked list, comma, traversing in my linked list. So we are going to create methods by which we can insert elements in my linked list, delete element from my linked list, or traverse, or to perform various operations. We create functions, and by the functions we can add elements, we can delete elements, we can traverse, all those kind of things we can do in our linked list. Now let us understand how we can create our methods. Now let us talk about how we can create methods to add, to delete, or to remove, to traverse or to search a particular element in my linked list. Now let us proceed with our first method, that is adding operations in our linked list. So we can basically add our linked list in three ways. That is, we can add at middle, or we can add at last, or we can add at a particular given index. So user will give us index and data, and we need to add that particular element at that particular index. We'll talk about it later, but for now let us see these two operations. So first of all, let us talk about add first operation. So how we can add elements in my linked list at first. So let us consider, to understand the concept of adding element at the beginning of my linked list, we need to take a linked list as example. So let us take an example, that is, let us consider that this is my linked list. Here we are having elements 2, 3, 4, and this is pointing to null. Okay. Now if I want to add one node in my linked list, this is a linked list, so if I want to add this particular element to this, how we can do this? We already know the terminologies. That is, the first one is, this is my head and this is my tail. So if I want to add a particular element to my linked list, how I can do that? We already know that a linked list, a node in my linked list will have two things, data and next. So here this node 1 will have two things, that is 1 and it next. So we can point, we already know that next variable will point to a corresponding node. So we can point this particular node, to 1. So here I can do that. Let us consider that this is my 1 and it is having its next. So I can point these next to my head. So let us consider that this is my new node. So I can pass new node dot next. New node dot next is equals to head. And after that, I can change the value of head. This is the head now. After pointing, I can change my head value. So my head will become this. That is, head is equals to new node. This is how I can add elements in my linked list at the very beginning. So what are the things going on here? First step is to add at first. We are creating a new node. Create new node. And here we need to understand the base case. That is, if my node is empty, if my linked list is empty, that is, head is equals to null. Initially, if my head is equals to null, then what we can do? We can do head. Let us consider that there is no linked list here. So if I am creating a new node in my linked list, that is, let us consider this is my new node, and if I create a new node in my linked list and there is no existing elements before, then this particular new node will become head and this particular new node will become tail. Yeah, so here head is equals to tail is equals to new node, right? If the linked list is empty, else 2.1 step. That is, here first of all what we are doing, we are creating new node and we are giving it value, we are giving it reference, all those kind of things. After that, if the node is not empty, that is, the linked list is not empty, then first of all the new node dot next is pointing to my existing head. So new node dot next is equals to head. After that, head, the third step will be head is equals to new node. That's all. I'm changing the value of head. So by performing these 3 steps, we can add elements in my linked list. Now let us code this thing. So here I'm going to create my function for adding at the very beginning. Add first. First. Now I'm creating my function public void type function because I'm not gonna return anything. Void add first. In the add first function, I'm going to give some data, int data. After that, what is my first step? First step is create new node. This is my first step. So creating new node. How we can create new node? Node. Let us say the variable name is new node is equals to new node. Here I am passing data. Okay. After that, now new node is created. The second step is checking. The second step, 2.1 step, is check if head is equals to null. That is empty linked list. So here, if my head is equals to null, then what we are supposed to do? We are supposed to do head is equals to tail is equals to new node. That's all. Else, if this is not the case, there are elements present in my linked list, then my 2.2 step is change new node dot next is equals to head, and after that head is equals to my new node. These are the steps I need to perform here. So here new node dot next is equals to my head. After that, head is equals to my new node. That's all. This is how I can add elements to my like at the very beginning of my list. So instead of writing ll dot head, I can remove this and I can do ll dot add first, and in this I am passing, let us say I am passing 1. After that I can also add let us say I am adding elements as 3. After that I can add ll dot add first 2. After that ll dot add first 3. So this is how I can add elements at the very beginning of my linked list. Now let us understand how we can add at the last of my linked list. So we have studied how we can add elements at the first. Now let us see how we can add elements at the last. So to understand how we can add like our element at the last of my linked list, I am going to visualize a linked list. So let us take a linked list 1. It has its next 2, 3, and it is pointing to null. Suppose I have created a new node that is 4, and it will have its next. So how we can add this particular node at the last of my linked list? So this is my head and this is my tail. So adding last is also very similar. So the adding first operation and adding last operation will take time complexity around big of 1. That is, we are just like checking and we are just adding, we are performing single operation. That's why it is taking big of 1 time. Now let us see how we can add our new node to my tail. So this is my tail. So you can observe that tail dot next is pointing to null. So in the place of null, if I change this next to this particular element, that is, if tail dot next will point to my new node, let us consider that this is my new node. So if it points to new node and this new node will points to null, that is new node dot next will point to null. So by performing these 2 steps, we can add my new node at the last of my linked list. So this is how the process will be. Let us consider that this is my list, right? 1, 2, 3. So this is my tail. So instead of pointing null, what I am doing, I am pointing to 4, and these 4 will point to null, and this connection will be breaked automatically. So this is how I'm going to like add my element at the last. So what are the steps we are doing here? First step is creating my list, creating new node. After that, second one is checking if my list is empty or not. 2.1 is checking if head is equals to null. If head is equals to null, then what we are going to do here, that is head is equals to tail is equals to my new node. else, that is my list is not empty, then what we are doing here, that is tail dot next is equals to my new node. My new node, after the third step will be new node dot next is equals to null. This is how we are going to add my element at the last. Now let us code this thing. So let us create a function for add last. So for adding last, I am going to create my function public void type function add last. Add last, here I am passing my data into data. After reaching my node new node is equals to new node of data. After that, first step is completed. Creating my, this is my first step, create new node, and the second step is, in the second step 2.1 step, in the 2.1 step checking if LL is empty or not, that is our linked list is empty or not. If head is equals to null, if head is equals to null, then what we are supposed to do, head is equals to tail is equals to new node, that's all. Else change the value, that is a 2.2 step, what here, tail dot next is equals to new node. So tail dot next is equals to my new node. After that, the third step is new node dot next is equals to new node dot next is equals to null, that is new node dot next is equals to null. After that, here we need to change the tail value. So if I add the element at the last, then tail will be changed, right? So here I am giving tail is equals to new node, that's all. This is a step of changing tail. So this is how I am going to add my element at the very last. So here I can add my elements as a ll dot add last for ll dot add elements at 5. So this is how we have seen how to add elements at first, how to add elements at last. Now let us see how we can print my linked list. So in the previous example we have created, in the previous code we have created a linked list. 1 is pointing to 2, 2 is pointing to 3, 3 is pointing to 4, 4 is pointing to 5, and 5 is pointing to null. So we have created these linked list in my VS Code. Now let us see how we can print these elements in my compiler. So to print, let us take terminologies. So this is my head, we already know, and this is my tail here. So we already know what is tail and what is head. Now how we can print? So I am writing here, first of all, first step will be to print elements in my linked list. I am creating a new node, let us say I am creating a temporary node. So this temporary node will hold the value of head. After that, by using head, I will reverse throughout my linked list. Now let us see the pseudocode of it. So first of all, I am creating my function public static void type function void print, and in this I am creating my node temp. So here in the node temp I am going to store the head value. After that, while my temp is not equals to null, that is initially my temporary is this, right? While my temp is not equals to null, what I am going to do, first of all I am going to print system.out.print temporary data. Whatever the data present in my temporary node, I am going to print it. After that I am going to alter, I am going to change temp is equals to temp dot next. That's all. After it, finally a single line, next line. So this is how I'm going to print. So what is happening here? Let us understand that here I have created a temporary variable that is storing the head value. After that, first of all, in the while loop, let us see what is happening. Let us consider that this is my output window. So here first of all I am printing temporary dot data. So 1 will be printed here. After that, temporary will change to temp.next, that is temporary will become 2. After that I am printing 2. After that here temporary will get changed again, so I will print 3. After temporary will get changed again, 4, I will print 4. After that 4 temporary will change to be to 5, and 5 after temporary will become null. So these condition will get like false. After that I will come out of loop, that's all. So you can see that I have printed all the elements in my linked list. So this is how I'm going to print the elements in my linked list. Now let us code this thing. So printing elements in my linked list. So for printing, what we are going to do here, first of all I'm creating my function public void, let us say print is my function. So print, here first of all initially I'm going to create my new node, temporary node temp is equals to, it is going to store the value of head. After that, while my head, my temp is not equals to null, then first of all I'm going to print system.out my temp.data plus its reference. That's all. After that I'm going to change the value of temp is equals to temp.next. That's all. After that finally I'm going to print my next line. That's all. Here you can see that I have created a linked list. Add first 1 2 1 2 3. We have added elements here 4 5. So if I run this, let us call my function ll.print. Now let me save and run. Let us see what output we'll get by running this like program. So you can see that we got the output as 541 51234. Let us see what is happening here. Here I am adding first, I need to add last here, so add last. After that here, this is the thing happening here. Here after that null. That's all. Now let me save and run. So you can see that we got the linked list. That is, first of all initially I am adding 3, so 3 will be here. After that I am adding 2. So 2 will be coming here, adding first. So 2 come will here. After that I am adding 1, so 1 will come here. After that I am adding last at the last, so 4 will come here. After that 5 will come at the very last. So after printing I am giving here you can see that I am printing all the data. After that I am changing the value of temp, and finally after printing all the things I am printing our null value. That's all. So this is how we'll print the elements in my linked list. Now let us see how we can add elements in my linked list at a particular given index. User will give me index and data. Let us consider that user has given me index as 1 and data is 0. So to add element at the like given index, what are the steps we need to perform? So to understand that, let us take a linked list as an example. So here I am taking a linked list as example 1 2 3 4, and it is pointing to null. Okay, so here this is my head and this is my tail, obviously. So what are the steps here? The first step will be create new node, and if head is equals to null, that is no elements present in my linked list, then head is equals to tail is equals to my new node. This is a simple step. And the second step will be, if the linked list is not null, then I am going to create two temporary variable, node t1 and it is pointing to head. After that, node t2 is equals to head dot next. You need to observe this very very clearly, node dot head dot next. So this is my t1 and this is my t2. The indexes are 0 1 2 3. So I need to add my element at the 0th index. Okay, so here I am going to create my iterator to keep a track between my index and my particular, like you can say given index and the index of my linked list. To keep a track, I am going to create an iterator int c is equals to 0. After that, I'm going to run a while loop while my C is less than idx minus 1. In this, if this particular condition is true, then we'll come inside the linked list, and I'm going to change t1 is equals to t1 dot next. After t2 is equals to t2 dot next. If this particular condition is false, then we'll come out of the loop. And what are the steps I'm going to do? I'm going to do t1 dot next is equals to my new node. After that, new node dot next is equals to t2. That's all. This is how I'm going to insert my linked element, particular element at the given index. Now let us see what is happening here. So this is my first element, second element, third, fourth, and this is pointing to null 0, 1, 2, 3. So I need to add my element at the first index. So this is my t1 and this is my t2, right? Okay. Now initially C is equals to 0 and given idx is equals to 1. So the condition is 0 should be less than 1 minus 1. That is 0 is not less than or equals to 0. Condition is false. So I will come out of the loop, and what I will do, t1 dot next. So the t1, instead of pointing, t1 now is pointing to 2. Instead of pointing to this, I will point to my new node, that is 0. So 0 t1 dot next will point to my new node, and new node dot next will point to my t2. This is how I'm going to add my elements in my linked list at a particular given index. Now let us code this thing. So add at a given index. For adding, I'm going to create my function public void add. In this, I'm going to get two things, int index, after that int data, what data you want to add, right? Okay, now here first of all I'm going to create my node new node is equals to new node of data. After that, the first step is completed. The second step is if head is equals to null, then head is equals to tail is equals to null is equals to new node. Else, what are the things we are going to do? I am going to create two temporary variables, int temp1 is equals to head. After that, node temp2 is equals to head dot next. After that, I'm going to run a loop while. Before that, I need to create my iterator, int c is equals to 0, and while my c is less than idx minus 1, and here what I'm going to do, temporary 1 is equals to temporary 1 dot next. I'm going to change the value of temporary 1 and temporary 2. Temporary 2 is equals to temporary 2 dot next. Next, after that, here I'm adding temporary 1 dot next. Next is equals to my new node. After that, new node dot next is equals to my temporary 2. That's all. So this is how I'm going to perform the addition operation at a particular given index. Now suppose here I'm going to add. First of all, here I'm adding ll dot add, and at the first index I'm adding 0. After that, I'm printing my linked list, ll dot print. I'm printing my linked list. Now let me save and run. So you can see that initially here I need to give next line. Here I need to give system.out.print a next line. That's all. Now let me save and run. So you can see that first of all, initially this is my linked list 1, 2, 3, 4, 5. After at the 0th index, at the first index, I'm adding 0 as my value. So at the first index, I'm adding 0. So here the first index is at the first index I'm adding 0. So this is my changed linked list. So this is how I can add elements in my linked list. Now let us see how I can see the size of my linked list. Let us see how we can calculate the size of the given linked list. So for that, let us consider a linked list 1, 2, 3, and it is pointing to null. So here the size of the linked list is 3. So what are the steps we have to do here? First of all, I will write the pseudocode public static void type function, and let me give size function. Size as the name of my function. So if head is equals to null, that is no elements present in my linked list, then return 0. Else what I am going to do, I am going to create a count variable int count. Count will keep track on the size of my linked list. Int count is equals to 1. After that, I am going to create a temporary variable int temp is equals to head, and after that, while I am going to run a loop while temp dot next is not equals to null, then temp is equals to temp dot next. After that, do count plus plus. Right, after that, finally return my count value. Here int data type, because I am returning integer, so int return count. So here what is going on here, this is my linked list 1, 2, 3 and null. Okay, this is my temp. Temp is nothing but my head. So initially c is equals to 1. So while temp dot next is not equals to null, right? So I will come inside the loop and I will change the temp value. After that, I will increment c++. So the c value will become 2. After this is my temp, and temp next is not equals to null. So I will change temp, and temp will be this. So I will increment c to 3. After temp dot next is equals to null now. So I will come out of the loop and I will return 3 value. So this is how I can calculate the size of my linked list. Now let us code this thing. Size of my linked list. So for that, I am going to create function public int size. After that, here initially I am going to create my new node. Before that, if head is equals to null, if head is equals to null, then basically return 0. Else create count variable int count is equals to 1. After that, node temp is equals to head. After that, while temp dot next is not equals to null, here temp is equals to temp dot next. After that, count plus plus. That's all, and finally return count value. So in the main program, I am printing whatever the value that is returned by my size function. So ll dot size. That's all. Now let me save and run. So first of all, I will be printing my linked list, and here you can see that this is my final linked list. Here 5, 0, 1, 2, 3, 4, 5, 6 elements are present. So I will print the size is 6. So this is how I can calculate the size of my linked list. Now let us see how we can remove element at the first and at the last. So how we can remove, let us talk about how we can remove the element at the very beginning of my linked list. So let us consider that this is my linked list 1, 2, 3, 4 and it is pointing to null. So I want to delete the first element of my linked list. So to do that, what is the thing I am going to do? First of all, here this is my head. So instead of creating new node and all those kind of thing, I am just changing the head value. That's all. By changing the head value, the first node will automatically get deleted. So here the step we need to perform is head is equals to head dot next. So by performing this single step, we can delete the elements in my linked list. By just changing the value of head, this first node will get separated from the rest of my linked list. So when it gets separated from the rest of my linked list, then garbage collector will automatically delete this particular element in Java. So let us see how we can code this thing. So for that, first of all, I'm going to create my function public void int type function because I am returning the value of the removed element. After that, function name remove first. Remove, here I need to give first. In this, first of all, if head is equals to null, if head is equals to null, then simply return -1. Else, what we need to do here, it is showing some this method must return, okay, this method must return something. Yeah, here I am creating a variable int val is equals to head dot data. After it, I am changing the value of head is equals to head dot next. After it, I am returning the value. That's all. Now here let me give system dot out first element is removed. Before that, let me call my function. I'm calling my function here the first element removed plus I'm calling my function that is remove ll dot remove first. That's all. Now let me save and run. Let me comment this all out. Yeah, I'm not printing my linked list here, just removing the first element. Now let me see here. Let me first print the linked list. After that, remove the element. So you can see that here I am printing my element and I have removed the first element in my linked list. So by just performing these three lines, we can delete the element in my linked list at the beginning. Now let us see how we can delete element at the last of my linked list. To remove element at the last of my linked list, let us consider a linked list that is 1, 2, 3 and it is pointing to null. Okay, so to remove the last element, this is my tail, right? So here I need to run a loop So first of all, I am creating a node temp is equals to head. Node temp is equals to head, and the second step is while my temp dot next is not equals to my tail. Until that, I am going to change my temp value. Temp is equals to temp dot next. After that, here, if my temporary is this, then I am directly pointing to my temp dot next. Instead of pointing to tail, I am directly pointing to null. So next is equals to null. After that, tail is equals to my temp value. That's all. So automatically the Java collection framework will delete this particular tail and my tail value will become this. So this is how I'm going to add my element at the last. Now let us code this thing. Remove last. So to remove elements at the last of my linked list, I'm going to write public int remove last. In this, first of all, if my head is equals to null, that is no elements present, then head is equals to null. In this case, I am returning -1. Return -1. -1 will show that no elements present at that particular linked list. After that, here, first of all, I am creating node temp is equals to head. After that, while temp dot next is not equals to tail, then I am going to change temp value. Temp is equals to temp dot next. After that, I am going to store the value int tail value. Before deleting the tail, I am going to store the value int val is equals to tail dot data. After that, here I am going to delete the value. I am going to delete the tail value, the present tail value. So here, what we need to do, I need to do temp dot next is equals to, instead of it is pointing to tail now, instead of pointing to tail, I am directly pointing to null. After that, tail is equals to temp. That's all. And finally, return my value, val. That's all. Now let me save, and instead of printing remove first, I am printing remove last function. Now let me save and run. So you can see that in the present linked list, the last element is 5. So here I am printing the last here, instead of first I have to print last. So last element is removed. Yeah, last element is removed. So 5 is removed from my linked list. So this is how we will perform add first, remove first, and remove last operations in my linked list. So up to now we have seen how we can print element, how we can print our linked list: add first, add last, add middle, remove first, remove last, and traversing through my linked list. Now let us see how we can search the given element in my linked list. So let us consider that here the given question is search for a key in my linked list, return the position of my linked list. If it is not present, then return -1. So let us consider that this is my linked list 1, 2, 3, 4. So here I am searching, let us consider I am searching 4 or I am searching 3. So the index is 0, 1, 2, 3. So if I am searching 3, then I need to return 2, that is its index. So let us see how we can do that. So to do that, I am going to create my function, a method basically, that is public static int type function, because I am going to return a integer value. Search, here the user will give me value. After that, here if my head is equals to null, if my head is equals to null, that is the list is empty, then basically return -1. Else what I am going to do, I am going to create a temporary node, temp is equals to hold the value of head. After that, I am going to create int c is equals to 0. C is equals to 0. After that, my while my temp dot next is not equals to null. In this, inside the thing, I am checking if my temp dot data is equals to my given value. If it is the case, then I am going to return c value. Else I am going to change the value of temp is equals to temp dot next, and I am going to alter the c value, that is c plus increment c. That's all. If the O loop is run but I didn't get my required element, then I am going to return -1. So this is how the process will be. So initially here you can see that this is my linked list 1, 2, 3, 4. So this is my linked list, right? And the given values, val is equals to 3 here. So here I will come here temp is equals to 1. So I will come inside the loop, that is temp dot next is not equals to null. Condition is true, I will come inside the loop. So I am going to check whether this value, temporary value, and the given given value from the user are same. If both are same, then I am going to return the c value. Else what I am going to do, this is my temporary, right? So I am going to change temporary, and initially c is equals to 0. I am going to change c is equals to 1. After this is my temporary value is 2 and the given value is 3, not same. So again change the value of temporary. So temporary will become 3 and c value will become 2. So here the given value is 3 and temporary value is 3. Both are same. If both are same, then what we are going to do, we are going to return the value of c. So 2 will be returned to my user. That's all. So this is how we are going to perform searching operations in my given code, in my given linked list. So to perform search operation, first of all I am going to create my function public int, let us say search is my name of the function, search. In this, user will give me some value. After that, here if head is equals to null, If head is equals to null, that is my linked list is empty, then simply return -1. -1. Else what we are going to do here, else head is equals to null. Okay. Now I'm going to create my node temp is equals to head. After that, while, before that iterator to keep track of my indexes, int c is equals to 0. After that, while my temp dot next is not equals to null. Here, if temp dot data is equals to given value, then simply return c value. Else change the value of temporary temp is equals to temp dot next. After that, increment c++. If the old loop is run but we didn't get the required element, then the element is not present, so return -1. That's all. Now here I'm going to search ll dot search. I'm going to search 0 in my linked list. In my above linked list, I'm going to search 0. Now index is save and run. So you can see that this is my linked list 1, 0 and so on. You can see that the index of my 0th element is 1. So I got my output as index is 1. That's all. So this is how I am going to search a particular element in my linked list. So up to now we have studied adding in my linked list, removing element, searching, traversing. We have studied basically all the basic concepts of my linked list. Now let us do some questions which are kind of interesting and simple questions.